Good morning, everyone. So today is about wrapping up our domain restriction knowledge and starting function operations. So this was our stamp. Apologies, I'm starting the video just a little bit late. Let's review what we did for the stamp. In black are the questions that we started with. So for number 1, we discussed in class how 3x to the 5th plus 2x plus 1. We did not explicitly talk about if something is to the 5th or to the 6th or to the 7th, but any polynomial written like this is always going to be all real numbers. This number just has an effect on the number of turns in the middle of the u. So just so you can see what that graph looks like, if it's to the 5th, it means I have 4 turns. So it would be 1, 2, 3, 4, 5. Kind of a funky looking graph, but pretty cool. So I clearly see if I came in from the left or the right, I have no restrictions. It's negative infinity to infinity. But I wouldn't expect you to have to graph this to know that. If I look at this function, I do not see an even root and I do not see a rational function, meaning x in the denominator. So therefore, I automatically know all real numbers. In class, we discussed how number 2, we have to start getting comfortable with this fraction notation. X to the 1/7 is the same as the 7th root of x. That makes it an odd root, therefore it's all real numbers. And before we moved on to number 3, we went up here and tried another example, where I provided you with s of x equals x to the 1/6, which becomes or can be rewritten as the 6th root of x. This is an even root, so that would have a restriction of all real numbers x greater than or equal to 0. We then came down here to number 3. We have a rational function, meaning I have x in the denominator. So our process is to pay attention to just what's in the denominator, set it equal to 0. Everybody solved and got x equals negative 2/5. That means that this is the value that needs to be excluded or removed from my domain. So my answer is all real numbers x not equal to that value. Again, because if we plugged this value in here, it would cause 0 to be in the denominator, and that's not okay. We can't divide by 0. In number 4, we have an example of an even root. Yesterday, we established that we cannot take the square root of a negative number. So again, I pay attention to only what's underneath the radical. If I had a plus 10 out here, it wouldn't mean anything. I still only pay attention to what's underneath. We take what's underneath the radical, set it greater than or equal to 0, and solve. This then translates right into my domain, all real numbers, x greater than or equal to negative 5, and I'm done. Number 5 is an odd root. Yesterday we looked at that graph. They look something like that, or like this. These never have a restriction. So if it's an odd root, no restrictions, all real numbers. And right now, everybody is working on a wrap-up practice, which we are about to start to review as a class. All right, folks, let's come together. Let's come together and start talking about what we have going on here. For number 1, what are our thoughts? Yes. What are you thinking? What kind of function is this? Let's talk about that first. How do you know that this has a restriction? Why are you paying attention to that? True. So in general, that's called a what? Even root. So we are going to make this a master set of review questions. So if you want to highlight this, put even root next to this and highlight it. That's what this is. That's why it has a restriction. And then, which part of this do I need to pay attention to? She mentioned it. Just underneath the root. So take your highlighter again. Take your highlighter again and just highlight the x plus 5. Do we care about the minus 7? No. Do we care about the negative 2 out front? No. Great job. Keep going. Correct. We're going to set what's underneath the radical greater than or equal to 0. And when I solve this, I get x is greater than or equal to negative 5. This translates directly to my answer, all real numbers, x greater than or equal to negative 5. And we're done. How about number 2? This looks crazy. But it's really not bad. Why? It is an even root. What is the only piece of this I have to pay attention to? Just underneath the radical. So again, take your highlighter and just highlight just highlight what's underneath the radical. Do we care about the plus 6? No. Do I care about the 1/2? No. So what inequality am I about to write? What's greater than or equal to? 8 minus 4x greater than or equal to? 0. So we're going to subtract 8 from both sides. When I divide by a negative, what happens to my inequality sign? Changes direction. Good. So now I have x is less than or equal to 2. All real numbers, x less than or equal to 2. So check. Did you allow that inequality sign to switch directions the way it needed to? Did we keep track of our negatives? Number 3 is a giant shout out to what we had talked about in the warm-up with what this notation means. If I don't want to have to work with 1/2 as a power, how could I rewrite this? These mean the same. These mean the same. When something is raised to the 1/2, all that means is square root. It's the same notation. So now that I see it this way, what do I clearly see this is? Again, an even root. It's an even root in disguise. Yes? Yep, greater than or equal to? Great question. So her question was, why do we always set, because that's what we're about to do, right? We're going to take 2/3 x plus 3 and set it greater than or equal to 0. What can you not take the square root of? What can you not take an even root of? What kind of number? Negatives. So we're saying I need to figure out what value of x is okay. I figure that out by actually setting this greater than or equal to 0 and solving. And because what's underneath the root changes all the time, our answer is going to change all the time, which is why we have to do it every time. Great question. Again, we can take our highlighter, just pay attention to what's underneath. This one's a little more simple because I don't have anything over here or in front. What did you guys get when you saw this? Let's see. I'm going to subtract 3 from both sides. We agree about that? Okay. And then what am I going to multiply by to clear this fraction?
3.
Not just 3. The reciprocal of that fraction. So we get x is greater than or equal to -9/2. Good job. You can either keep that or I can simplify that to be what decimal? Yeah, totally up to you. What did you guys keep? What do you want to keep? The 4.5? Whatever makes you happy. Either works. This might be a little easier to actually work with and see on a number line, but I would accept either answer. Great job. Number 4. How can I rewrite number 4? Question. I hear the word root, so I know that we know we're going to write a root. Is 10 underneath the root? No. Good job. Good question. Why is that? For 10 to be underneath the root, I would have had to have this. See the difference? If I had been given this, 10 would be under the root. But that's not the case. So 10 stays outside. So no math is involved in this answer. What's my domain? All real numbers. Because if I highlight what's underneath the radical, What's the only thing there? X. So when I say let's set what's underneath the radical greater than or equal to 0, right away, if I do that, x greater than or equal to 0. Any solving? No, no solving. Great job. Number 5. What kind of function is this? Rational. Let's get very comfortable with that word. Rational function. And all that means is that we have x in the denominator. What can I not divide by in math? 0. So we're going to force this to be 0 to figure out what x cannot be. Let me say that again. We cannot divide by 0. So we're going to take the denominator. Let's highlight the denominator. We're going to take that denominator, say, well, let's let it equal 0. Whatever number we get is what x cannot be. So what can x not be? Very good. Because when I solve this, I get negative 9. That means that this is what would make that 0. I have to exclude it. X not equal to negative 9. Number 6, what kind of function? Rational again. Why is this rational? Yes, because x is in the denominator. We highlight our denominator, like so. We're going to take x squared minus 16 and do what? Equal to 0. Good. This is going to be a shout out to solving last year. I add 16 to both sides. That's going to get me x squared equals 16. Ooh. Square it? Square root it. Take the square root of both sides. How many answers do you get from this? Very good. What are my two answers? Plus or minus 4. So all real numbers, x not equal to plus or minus 4. Does anybody remember why we get two answers? Good job. So for anybody who didn't, I heard a multitude of all correct answers, which was great. Let me just voice the common thread of what everybody said. The reason we get two answers is because if I look at x squared equals 16, 4 squared is 16, and so is negative 4 squared. So I have two solutions. What about number 7? Odd root. Odd root, all real numbers. Number 8. Ignore this, ignore this. You are just paying attention to our restrictions. What are we thinking? It does restrict 4. Because this is x less than 4, this is x greater than 4. Neither of these say that it can also be equal to. Perfectly fine. So you could also write this. Just as good. All right. One more. Number 9. All real numbers. Very good. When in doubt, if there's a function that we haven't technically seen, if it's not rational, meaning you don't have a fraction with x in the denominator, and it's not an even root, and I don't have a given restriction like the piecewise, what's always going to be my domain? All real numbers. Fantastic. Okay, switching gears. I need 2 passers. We're going to start function operations, but we're going to actually do it in a kind of a cool way. We're going to start with a geometry connection. We'll talk. Can I get a passer for this side? Thank you. Great question. So she's asking, how did we get not equal to 4 from this? I don't want you to overthink this. I literally want, if I gave you a number line, and I asked you to graph this, yes? And we put 4 on this number line, how would you graph x is less than 4? What would you do? open circle on 4, and then go which way? Left? So that took care of this one. And then how would you graph x is greater than 4? Still open circle on 4, and then to the right. Exactly. Exactly. So whenever you're working with a piecewise, if it helps, sketch yourself a little number line. Great question. All right, geometry connection. How cool is this? Love it. It's going to be great. We're going to work on this together. I know, right? So excited. Write and simplify an expression for the area. Blast from the past. How do we calculate area? Length times width? So here, instead of having numbers, we now have expressions. What can we do with these two expressions? Multiply. So my area is going to be x plus 6 times 3x squared minus 7x plus 5. Get those arrows going. Let's figure out what we got. So first we're going to send in x. So x times 3x squared. What's x times 3x squared? 3x to the third. And we've got to warm up these multiplication skills here with exponents. X times negative 7x minus 7x squared. And then what's x times 5? Plus or minus? Good. Are you done? No, what do you got to send in? 6. Go for that. Send in 6. And then if you have like terms, we got to combine some of those like terms. Where are my like terms? Good. Remember, like terms, same variable raised to the same power. Notice how I'm including my signs in my boxes. It really does help out when we start combining. Did we have anything else like the 3x to the third? So we're just going to bring that down. What's negative 7x squared plus 18x squared? Plus or minus? Plus. And then a 5x plus 5x and minus 42x. Negative 37x. Do we all agree with that? How about that plus 30? What happens to the plus 30? Keep it, and we're done. Number 2, write and simplify an expression for the volume of a cube. Volume of a cube. What's volume? Volume equals length times width times height. So how am I going to do that? Good. So we're going to do, I hear this. This is good. How are we going to do that? Yes. Now what? I'd recommend tackling just the first two. Leave this one aside for a second. So just work on this. So we're going to do 2x times 2x, 4x squared, 2x times negative 3, so when I combine like terms, I now have 2x minus 3 times that. Do we agree? And now what do you still need to do? Send it in again. So this is literally a straight up exercise in algebra. Go ahead and finish, and then you can check answers with the person sitting next to you. Are we matching so far? That's what I got. Am I right or am I wrong? Did I do something wrong? Probably did. What did I do wrong? Good. Why is he right? Now are we good? Yeah. Otherwise? Oops, why did I still do that? Say that again. Because a negative 3 times a positive 9 is a minus 27 at the end. But did we get the same answer? Can we fix it? Yes. Fantastic. Tonight's homework is just to work on number 3 on this. Just to work on number 3. And then tomorrow we're going to start class off with our official function operation notes. Right? Today is Tuesday, so I will be after for a half hour. If anybody did not get their grade sheet yesterday, I did print them off again. So come see me, and I have quizzes to pass out. Nice job today. Come see me, grade sheets and quizzes. Have a great Tuesday.